Our next talk is on mod anti-malware, and it's presented by Neil Daswani. Neil is a co-founder and CTO of Daswani, and prior to that he ran a part of the security team at Google, and he also co-founded Advanced Security Certification Program at Stanford. Please give a warm welcome to Neil.
Thank you, Michael. Very good. So I'll be talking today about mod anti-malware, a pretty exciting web server module that we've built at Daswani for both Apache and IIS, and we'll talk about web-based malware infections in general. We'll talk about structural vulnerabilities on websites, and we'll of course talk about the module itself as well as its design and architecture. But before I get into the meat of the material though, what I would like to do is just let you know that we're going to have a couple giveaways at the end of the talk. So I published this book, Foundations of Security, while I was at Google, and I'll be raffling off a copy at the end of the talk. In addition, I'm not quite sure how many folks have heard of Daswani. We started in late 2008, so while the world's legitimate economies were falling through the floor in late 2008, the world's cyber criminal economies were of course going through the equivalent of a boom, and we had raised our first round of financing at that time from a pretty well-esteemed group of folks. And so what I'll be doing is at the end of the talk I will be raffling off or actually I'll just be giving out some passes to a private party that we're throwing this evening. At Daswani we have been working with a variety of companies, a variety of customers, and I'll tell you a little bit about what Daswani does as a business just kind of throughout the course of this talk, but I'm going to be specifically focusing on mod anti-malware. So let's see, if anybody, by the way, has any questions, and this is kind of a big room, but if anybody does have questions, feel free to raise your hand. I'm not quite sure if we have mics, but I'd be happy to take questions. In fact, I may reserve, say 10, 15 minutes at the end of the talk specifically to focus on questions that folks might have. So with those preliminaries out of the way, let me go ahead and get into the meat of the matter. The work that I'm going to be presenting on mod anti-malware is joint work that has been done together with a number of other folks at Daswani. So one thing that I want to mention is that the way that malware has been spreading on the internet has fundamentally changed over the past few years. It used to be the case that most malware would spread as, say, attachments to email, and people would get infected when they clicked on the emails, and it would go into their contact list and spread to other folks in their contact lists. Of course, what's happened over the past 3 to 4 years is that an increasing amount of malware is getting spread by compromising legitimate websites. And I'll talk about a number of the different ways that legitimate websites are getting compromised, but the key thing that the attackers are doing is taking legitimate websites and turning them into distribution vehicles for their malware, such that when users happen to visit compromised legitimate websites, they will simply get infected just by loading the page in their browser. And because of the virulence of these attacks, the major search engine providers, the major browser companies, the major traditional antivirus players have been taking a very aggressive stance with regards to addressing drive-by downloads as well as other forms of web-based malware. So these attacks have not only been hurting users, but they've also been hurting the enterprises and the websites that are effectively being used as the intermediate victims in these types of attacks. So there's a number of negative ramifications that the businesses, enterprises, websites suffer from when their websites get compromised and turned into a delivery vehicle for malware. So for instance, I'll give a couple examples. When a website gets infected and is used to spread web-based malware, drive-by downloads and the such, Google as well as major search engines will do things like in their search results, they will add annotations to the search results saying that this site may harm your computer. And if users attempt to simply even click on those links, instead of taking the users to those sites, Google, for instance, will return an interstitial page which will say, really, we're not kidding, this site's going to harm your computer. You should think very hard before going there. In fact, when Google initially released those interstitial pages, they still used to include a link to the infected websites, and they found that so many users still clicked on that link anyway that they took the link off. So that's one thing that Google's doing, but basically if you look at Yahoo, for instance, in their search results will flag sites that are sending down dangerous downloads. If you look at Microsoft's Bing, the smart screen filter technology that's built into the IE browser is also used to send information to Bing such that users can be protected from malicious websites or compromised websites in the search results. In addition, the information about these compromised websites is being shared with browser companies. So if you look at Firefox, if you look at Chrome, if you look at Safari, they are incorporating data from Google and other sources about websites that have been compromised and infected, and when a user attempts to get to any one of those sites simply by browsing, casual surfing, as opposed to going through the search engine, they will, instead of seeing a website that might infect their computer, they'll see a red screen of death. So for instance, in Firefox, it'll show this screenshot up here on the left saying, reported attack site, don't go there. And there's been a whole variety of businesses, small, medium, and large, that have had such issues. To give a couple of examples, this past May, the US Treasury website had gotten infected, and they in fact had to take down some of their websites due to these kinds of infections. But it's been happening to a whole variety of organizations. So what happens is when these kinds of warnings are added to search results or these red screens of death are shown by browsers, it results in a very significant traffic loss for websites. There's some websites that might receive, for instance, 90 to 95% of their traffic from Google. And if the sites won't get served in the search results in the traditional way, then they can lose quite a bit of traffic. In addition, if the website is, say, an e-commerce site and they're selling services online or selling products online, then they effectively lose their ability to sell when these kinds of issues occur. If they're an online publisher that makes their revenue through ads on the site, then their ability to earn revenue from those ads also gets curtailed if users cannot find their way to those websites. So traffic and revenue loss is one of the major issues that occurs when web-based malware spreads. I had mentioned that in addition to the search engines and the browsers, there's the traditional antivirus players that are also taking a very aggressive stance to this. So if a user ends up at an infected website, however they get there, their client-side antivirus package may pop up a warning saying threat detected. That's, for instance, the warning that AVG will display when a user tries to get to a site. And it also, in addition to traffic and revenue loss, can just result in brand damage. People get scared to go to that site. In addition, there's a whole bunch of data theft and compliance liabilities that can occur. In fact, what I'd expect to happen over the next few years is that when businesses get impacted, what's going to happen at some point is there's going to be a lawyer that's going to inevitably end up at an infected website. A drive-by download is going to occur. That lawyer's machine is going to get infected. They're going to blame the website. They're going to sue the website. They're going to create a class action lawsuit, and the website that got compromised and turned into an intermediary victim for serving drive-by downloads and other web-based malware is going to get sued by that class action suit. So it's just a matter of time before these things happen. So web-based malware can significantly hurt enterprises. And so now that I've talked about the negative ramifications, let me talk about how these infections occur. And I am going to focus on a variety of infections. There's some types of infections and infection vectors that are more traditional than others, but let me talk about both the traditional as well as the non-traditional ones. So Looking at one vector of vulnerability, let's start with software vulnerabilities. Websites and web applications may have all kinds of software vulnerabilities in them. The website, if it's connected to a database, it may be vulnerable to a SQL injection attack. If the website happens to, say, take user input, even if it isn't connected to a database, it can be vulnerable to a cross-site scripting attack. If it's connected to a database, it could be vulnerable to a stored cross-site scripting attack. And bad guys can use those types of vulnerabilities not simply to steal data, as they have been used in very traditional ways, but those vulnerabilities can be used to inject malicious code into the databases that run the website. So what can happen is that the bad guys will inject malicious JavaScript and malicious iframes, say, into the header and footer of a website that happens to be a blog, or part of a website that happens to run a popular blogging package. There's also things like shopping carts, e-commerce packages. There's a whole variety of third-party applications that are used. And so that's one way that websites can get infected, through traditional web-based software vulnerabilities. For those of you that are familiar with the OWASP top 10, you know that those types of vulnerabilities can be used to inject data into a website and turn it into a malware delivery vehicle. In addition to software vulnerabilities, though, there's a whole bunch of other types of vulnerabilities as well. And one of the interesting things about web-based software vulnerabilities is that one can run a traditional vulnerability assessment, web-based web application vulnerability assessment, to find these issues and fix them and mitigate them. And of course that takes some time, but it's very doable. At the same time, there's a set of vulnerabilities that are not as easily preventable. And let me talk a little bit about what's been going on with Web 2.0 and external content and third-party dependencies. So one of the interesting trends that we've seen over the past 5 to 6 years with Web 2.0 is that no website exists in a silo anymore. Websites use a lot of third-party resources to bring their site together. So a website might have a page that's constructed with a set of mashups, a set of widgets, which include code, say JavaScript code or ActiveX code or whatever code from some other website. And one of the interesting things about this Web 2.0 trend is that if you look at many sites, they rely on a lot of third-party resources. And so you can think of these as issues where let me talk about how malware relates to this. So basically, if a piece of malware or if a bad guy or a cybercriminal compromises a widget that happens to be used by thousands of sites, then basically that widget effectively allows the attacker to distribute their malware to all those thousands of sites that use the widget. Now this is an interesting kind of vulnerability. This is a kind of vulnerability that is not a software implementation vulnerability, but is a structural vulnerability. And we at Daswani, we issued a research report just earlier this week on structural vulnerabilities. I'll spend a little bit of time about structural vulnerabilities, and then I'll talk about how mod anti-malware addresses structural vulnerabilities as well. But the key point here is that with Web 2.0 and the reliance on a lot of third-party resources, including widgets, including ads of various kinds, if the bad guys compromise those widgets, if they compromise the ads, then what happens is that every website that uses those widgets and ads also basically can be used to spread malware. So that's one thing that's very interesting about how the web has become more interconnected, and how Web 2.0 has, to an extent, increased the attack surface and given an additional platform for the attackers to spread web-based malware. So in addition to software vulnerabilities and structural vulnerabilities that come due to Web 2.0 type trends, there's a number of other vulnerabilities as well. So one thing that's interesting about the Web 2.0 vulnerabilities that I mentioned is that it's not anything that you can really prevent. Your site relies on third-party resources, and you probably want to mitigate the risk to that, but you don't want to necessarily take off those widgets, take off the ads. Along that vein of issues that are not, say, as easily preventable are things like password compromise. So, for instance, there was a web worm called Gumblar, which last May spread and infected approximately 80,000 web servers and web applications in just a few weeks. The way that it worked is the malware would get onto a user's PC, and if that user happened to be a web administrator and logged into their website using FTP, then what the malware would do is it would upload the compromised credentials to the Gumblar bot master, and that bot master would then automatically log in to the sites that were compromised and place more drive-by downloads on pages on that website, which resulted in additional webmasters accessing those pages, getting infected, getting their keystrokes logged, and getting their passwords, their FTP passwords, sent to the Gumblar botnet. So you could see how this basically created a cycle, and as a result, 80,000 web servers were able to get infected in a fairly short amount of time. So one might argue that, hey, you could choose passwords that are hard to guess or strong, but basically if there's malware on some webmaster's computer, they can keystroke log the password and their website can be used as a malware distribution vehicle. So this is also in the class of something that's not as easily preventable. But one theme that I'll mention is that in addition to prevention, while it's good to do as much prevention as you can, employing as much detection, containment, and recovery techniques as you can is a great way to employ defense in depth. And I'll talk about how that applies to web-based malware as well. So password compromise is another way for websites to get infected with web-based malware. And of course there's traditional infrastructure vulnerabilities. So if you're on a hosting platform and that hosting platform has a web server or an operating system that it's running, and there's a, say, network layer compromise or an OS level compromise, then the bad guy can of course do whatever they want. So that's yet another manner in which websites can be leveraged to become malware distribution vehicles. Make sense? Any questions? Great. Okay, good. So I talked about the term structural vulnerability. And what I thought I would do is offer a definition of what a structural vulnerability is, since it really hasn't been talked about in the field. And so I'll talk about some of the highlights of this definition. The way to think about structural vulnerability and how it's very different from a software implementation vulnerability is it's a weakness in a web page where the web page may be using some third-party component. And if that third-party component gets infected, then so does the entire web page. And so a structural vulnerability is such a weakness. One of the things that we did at so one thing I should also mention is that as I mentioned before, if your website has a structural vulnerability, it's not the case that you should start eliminating all the third-party widgets and code and ads that you use, but it's important to mitigate that risk so that if any of the resources that your website relies on gets infected, your website shouldn't get infected. You shouldn't be infecting users. So some examples are third-party JavaScripts, and some of these are very popular, some of these are not, right? So for instance, Google Analytics, if you on your website use Google Analytics, then if the Google Analytics domain, say, ever got compromised, then your website could be turned into a malware distribution vehicle. Now, Google, of course, I should mention, employs a lot of great defenses to make sure that their website and that Google Analytics doesn't get compromised, but there's a lot of different third-party widgets out there, and not every third-party widget company will have the same defenses in place. Another example is jQuery. It's a very commonly used widget, and it can either be hosted directly on your website, you can have the code there, or you could point off to some other website that hosts jQuery for you. In addition, there's a lot of websites that might use widgets like online surveys, where basically you could take part of your website and allow the user to fill out a poll. And of course, if this particular survey widget gets compromised and the bad guys, say, inject a malicious iframe or something else in there, then the website that's serving it turns into a malware drive-by download vehicle. And the attackers like to take advantage of these types of widgets because when they compromise the widget, they compromise lots of websites all at the same time. So those are just some examples. At Daswani, one of the things that we recently did to understand how big this problem can be is we ran a study where we looked at several thousand of the most popular Quantcast sites. Quantcast is a kind of a traffic measurement marketing company that ranks the websites that get the most traffic. So we looked at several thousand Quantcast sites and also looked at a whole bunch of Fortune 500 websites. And what we had found is we had basically run scans of these websites where we weren't looking for the malware itself. We can, of course, do that. But what we were looking for was structural vulnerabilities. We were looking at what third-party widgets, what third-party ads, what third-party applications were they using on the website. And we came up with some interesting results. So one of the things that we had found is that 3/4 of the sites on the internet use some form of third-party JavaScript widget. And of course, that can result in a structural vulnerability for the website. We had also looked at external advertisements, and we found that 82% of publishers run third-party ads on their website. So that was interesting. We also found that on average, a website on the internet has a 41% likelihood of running some kind of third-party ad. In addition, one thing that we thought was interesting is we ran this across different verticals. So of the Quantcast sites and the Fortune 500 sites, we categorized them by vertical and found that financial institutions were just as likely as other websites to run third-party advertising and use third-party ad widget resources of various kinds. And of course, if they become compromised, well, then so does the financial institution's website. So that covers the widgets, that covers the ads. In addition, we looked for third-party applications. You know, was there a content management package like a WordPress or a Joomla or a Drupal running on the site? Was there, a shopping cart? Was there, some other third-party application that wasn't built by the company whose domain runs the website? And we found that over 90% of businesses not only have third-party applications on their website, but they were running an outdated version of that third-party software that may have some vulnerability. And if you think about these things, one thing that's interesting is that this third-party reliance is a natural part of the internet, but the vulnerability that results the vulnerability that occurs as a result of having these issues is not well mitigated. So typically, what we've seen is that when websites get infected, say through a third party, there was in fact a case where there was a Quantcast 100 publisher that was using a very popular traffic management widget that got infected, and very often people find out when customers report it, or when they find it through other folks that report it, but or when a search engine flags the site, and that's not the ideal way to find out about a third party that's getting compromised. Let me talk about a couple more stats around structural vulnerabilities, and then talk about a number of things around how to address these issues and make sure that structural vulnerabilities on your website doesn't result in web-based malware infections. So I mentioned the overall stat that 75% of websites use third-party JavaScript widgets, but there's a couple verticals that rely on third-party JavaScript widgets even in a much more likely way. So consumer packaged goods websites, financial websites, high-tech websites, publisher websites, and travel and entertainment websites had a much higher reliance on third-party JavaScripts than otherwise. There was a number of companies that relied on third-party ads and third-party advertising-related resources. I had mentioned that it was surprising to me that financial institution and financially oriented websites ranked at 41%, which was just about average. And while it may not have been, say, the online banking part of the website, it may have been a part of the website where there's a community where people can share financial advice, for instance, where we'd see some such resources, or the website would be relying on a third-party ad widget to basically manage their own house ads and rotate them, etc. So that's where that came from. In addition, high-tech websites, retail websites, travel websites, and publisher websites had a significant reliance on third-party advertising. And by the way, advertising on the web can be a great thing. It's in fact funded the development of a lot of content and made a lot of business models possible. So I think that eliminating advertising on websites is not also the right way to go. But if there are structural vulnerabilities due to advertising on websites, it's important to just mitigate them. The third category of outdated web application and other software packages, we found that certain verticals here, retail, manufacturing, consumer packaged goods, publisher, and high tech, had a fairly high reliance on third-party packages. I think it's interesting that to note that most websites, use third-party software, and it's the fact that these are outdated shouldn't be super surprising. As we know from the client world, right? It's very hard to keep a lot of client-side machines up to date and patched, but the same exists on the servers, right? In fact, doing server-side patch management is even harder because you have databases, you have a lot of software code that may need to be upgraded or changed when you upgrade a particular application, and so that's a little bit as to why, why these numbers are where they are. So we've talked about structural vulnerabilities, in a lot of depth because it's something that we recently released, but there's pretty much a number of different categories, as I mentioned, of vulnerabilities: software implementation vulnerabilities, structural vulnerabilities, password compromise, etc. So the question is, given all of these types of vulnerabilities, how do we mitigate the problem of web-based malware, and how do we provide the quote-unquote complete lifecycle of malware protection for websites? Now, let me talk a little bit about what I mean by that. If you look at what goes on in the client-side world, when a client-side PC gets infected by a piece of malware, it's not the case that the antivirus package comes up and says, hey, the computer's infected, you have to stop using it. Right? That's not what happens. In fact, the client-side antivirus software will attempt to quarantine the malicious code or the malicious files and allow the user to continue using the computer. Unfortunately, if we look at what's going on in the world of the web, when a website gets infected and when a website is serving malware to its users, if we look at what's going on with the way that the search engines and the way that the browsers are currently handling this, the users pretty much cannot use the website anymore once the site is infected, which is to an extent the right thing for the search engines and the browser companies to do. They want to protect users. That is the right thing for them to do. Unfortunately, for the website, it has very negative repercussions sometimes, and it would be nice if we can move to a better model. Move to a model where even if a website does get infected, there be a way that we can provide the complete life cycle, not just the detection, but the containment and the recovery in an automated way as well. And so what I'm going to do is talk a little bit specifically about detection and containment, realizing, of course, that when you deal with any particular security problem, there's a number of different types of defenses that you want to deploy to have defense in depth. You want to be able to assess issues, you want to be able to prevent issues wherever you can, you want to detect, you want to contain, and you want to assure users and customers. But I'm going to focus specifically on detection and containment, and I'll talk about how mod anti-malware can provide the containment to today's world, which doesn't exist today. Make sense? Any quick questions? No? Good. Okay. So this is a hard problem. We need to bring the entire life cycle of protection to the web, and there's a number of kind of sub-problems that we need to address. One of the key problems that we need to address is that whenever a website gets infected, it's important to root cause exactly where the infection is coming from, because it could be due to a whole bunch of different things on that website. And you want to be able to root cause what happened in a targeted way. And if you think about this, this is a little bit different than, say, what a search engine or a browser or an AV provider needs to do, a traditional AV provider, that is. In those cases, they simply need to detect that the web page is infected and put up the appropriate messages. On the other hand, if we want to be able to contain the impact and we want to allow users to be able to continue to use the site, we need to figure out what is the root cause of the problem, what is the widget that's causing the problem, what is the ad that's causing the problem, etc. And identify that and basically strip that out, or basically make the website still usable, continue to serve it, but strip that out. So we need to root cause the problem. And so doing things like on a web server. So basically, what mod anti-malware does from the abstract for this talk is it's a web server module that's written for both Apache as well as IIS, that once installed on a web server, what it'll do is that if and when a website gets infected and a monitoring service of some kind detects it and sends over appropriate quarantining information to this web server module, that web server module will allow pages to continue to be served, but it'll strip it out in real time. It'll strip out the malicious code in real time. And in order to do that, it needs to be able to parse the page in real time really fast in a really high performance way, and basically continue to serve the pages. Note that one interesting thing about this approach where you have the web server and a web server module doing this containment is that it doesn't matter if there was some file on the web server that was infected, or there was some malicious code inserted into some part of the database that may be part of a, say, content management system. Wherever the infection is coming from, it's going to get stripped out before it gets served to the user. So it's a hard problem, and mod anti-malware is some pretty cool technology to address the problem. So to just talk a little bit more about this root cause issue. For those of you that are familiar with web-based malware, you know that there might be various cases where bad guys will inject JavaScript into a website. So they might inject this script source tag, which refers to some a.js file at external.com, typically some attacker domain. And when that JavaScript runs, it does a lot of interesting things. One of the things that it will do is it will fingerprint what browser the user is using, it'll fingerprint what version of the operating system the user is using, it'll fingerprint what are all the third-party browser plugins that are being used. And it will then leverage a database of exploits that the attackers have, and will choose the optimal exploit to serve, to basically take control of the user's machine. And while doing this fingerprinting process, it may generate additional code, it may generate additional scripts or iframes on the page. And so one of the key things here is that when this code unravels, there's a lot of intermediate code that gets generated. But if we're going to do a successful job of containing the problem, it's important to be able to trace back the lineage of all this code that eventually resulted in a drive-by download, and trace it back to the element in the top-level page that caused the problem. So when you do, so basically in order to contain the problem, you need to have really good detection. You need to have good detection that root causes what is the top level page element. So the detection technology needs to not only figure out what's the top level page, but the ideal detection should be behavioral. There's many detection algorithms that rely on signatures, but one of the downsides of signatures is that it may not be most effective in catching zero-day malware. And from what we've seen occurring in the world of web-based malware, most of the attacks are in fact 0 days. So there are 0 days which refer to new domains, which rely on all kinds of new techniques for exploiting. And so the detection should typically be behavioral. It should need to be able to compute the lineage back to the top level code snippet which resulted in the problem. And an ideal detection technology can leverage machine learning like techniques which for any web page that's analyzed generate tons of features of that web page and or signals that may indicate not only that there's some probability that the web page is infected, but that there's a overwhelmingly high probability that the web page is infected. And so there's some certain requirements for a detection service to be in place in order to do very solid containment. So anyhow, I talked a little bit about detection, but I'm going to spend most of the rest of the talk talking about the containment piece and talking about mod anti-malware. So what is the high-level architecture for mod anti-malware? The high-level architecture is one in which there is a client or a potential victim website that's running a web server on which we've installed mod anti-malware. And that's one side of the house. The other side of the house is the detection side of the house, where a good detection service should be able to crawl all the URLs on the web server, submit it to a set of content and malware analyzers, and basically generate a report for the webmaster, but also, more importantly with regards to quarantining, send over automated quarantining directives to mod anti-malware to contain the infection. Now, one thing I should mention about this architecture is that mod anti-malware is analogous to other web server modules for Apache, for instance, where if you install mod SSL, it will it'll basically hook in as a output filter, for instance. And one thing I should mention is that where it's different though is that it's a remotely managed web server module. So there's a set of problems that need to be solved with regards to making sure that the monitoring service can securely authenticate, can send over appropriate configuration directives, can do things like make sure to have those configuration directives go into effect without needing to restart the web server, because typically whenever you change a web server configuration you need to restart the thing. But if you want to provide solid containment, all these problems need to be solved such that the web server can just continue to function and incorporate the directives without having to restart. And so I'll talk about the technical details of how we get that to happen. Let's see. I think what I'll do at this point is, now that I've shown you the architecture, just show you mod anti-malware in action, and do that before I delve into the technical details. So because the wireless isn't working so well in this room, I'm going to show the demo using a video that I have here. And basically this video shows an example of Mr. Rogers' website getting infected, and shows how mod anti-malware quarantines Mr. Rogers' website. And so the reason we chose Mr. Rogers' website is because this is motivated based on a true story. Mr. Rogers' website got infected in the early part of 2009. One of my co-founders actually reached out to their hosting provider and helped clean up Mr. Rogers' website. So it's it's an example that we chose and mocked up because it's based on a true story. And then the other thing that it illustrates is that the attackers just have no shame, right? The cyber criminals have no shame. They'll attack whomever, whatever. I used to love Mr. Rogers as a kid. I don't know if any of you folks did as well, but it's just kind of unfortunate that the bad guys are infecting children accessing websites. The movie doesn't have audio, so we should be in good shape. I'll supplement the audio. Great. Okay, our tech staff got a little worried. In any case, so we have Mr. Rogers' website, and in this version of Mr. Rogers' website, it's been infected, and that infection has been depicted using the skeletons on the page. Of course, in a real attack, this would be an invisible iframe instead of being a visible iframe. And the other thing that I should mention about it is that in a real attack, of course, it'll serve the drive-by download. So this website, Mr. Rogers' website, is being monitored by Daswani in this case, and Mr. Rogers' website also has the mod anti-malware web server extension deployed on it. So when the website is when the infection on the website is detected, the user, either the security team or the webmaster, will receive a email alert that looks like this, which says that there has been an infection detected, and that the site may very well be infected, and you can click here to view a report. So pretty much when the webmaster or the security team clicks here to view the full report, it'll take the user to a page on Daswani.com in this case, because we're running the monitoring service. And what it'll do is it'll identify that the website is at risk for being blacklisted by Google, by McAfee Site Advisor, by Norton SafeWeb, because there's an infection on it. And in addition to the site being at risk for being blacklisted, one of the things that we identify is that the infection is on this particular page. It's on the URL /test, and the infection is due to a malicious iframe that has been injected into the page. Now, because the web server extension, because the mod anti-malware web server extension has been deployed, the security team or the webmaster also sees this in the report a checkbox that says quarantine these infected URLs to protect my users. And once that gets checked and the security team or webmaster clicks update, what happens is that the backend monitoring service, in this case at Daswani.com, will send automated quarantining instructions to the mod anti-malware module running on the web server. So a dialog box comes up saying that the quarantining has been enabled, and if we now go back to Mr. Rogers' website and simulate another user coming to the website, what we'll see is that once the quarantining directives go into effect, the page continues to get served, but the malware got automatically stripped out. So that's how mod anti-malware works in a nutshell. It basically provided, in this case, Mr. Rogers' website, business continuity, even in the case of an infection. If a search engine crawler was to visit Mr. Rogers' website, then even though it is infected, it will not blacklist the site because the malware is not being served because mod anti-malware is containing it. Makes sense? Any questions I can take about that? No? Oh, question. Go ahead. Oh, okay. So the question is, how does mod anti-malware distinguish something that's malicious versus, say, something that's just showing an image? And the answer to that is that mod anti-malware, because of the fact that it needs to perform in a very high efficient fashion, it doesn't make that distinction. Basically, the monitoring service on the back end made that distinction and send over an automated quarantining directive to mod anti-malware which said that, hey, this thing is bad, this iframe is bad, strip it out of the page, but continue to serve it in a high performance fashion. If mod anti-malware was written in a way where it had attempted to make that distinction, it would probably draw the performance of the web server down to down to a crawl, which would not be acceptable. Great. So let me jump back to the presentation. Let's see here. Question, go ahead. Actually, I hope the demo gods are with us here. I just want to make sure that the slideshow is in good shape, and then I'll take the question. Okay, question.
Sorry, I'm curious if you have some mechanism for setting some sort of rules, like I don't use iframes in my site, or I use one JavaScript thing and it's over here, so that you could, in sort of a global way, block that stuff.
So the question is there a way to say that I don't use iframes on my site? Well, in the case that actually the I think the best way to answer that is to say that the monitoring service will not flag anything that isn't, say, serving a malware drive-by download. In this case, we basically told the monitoring service, hey, this image is bad, don't serve it. But in the more general case, because of the fact that the monitoring service is behavioral, so long as there's no malicious activity going on, nothing would get, say, inadvertently stripped out from the site, if that's one of the concerns. At the same time, because it's behavioral, if there is any element, regardless of whatever it is, if it's malicious and doing the bad thing, it'll get stripped out. So the thing is that it's dependent upon how the monitoring service works, and then of course you can write a monitoring service to configure it as you would like. Okay, great. Let me go ahead and continue forward. Actually, one more question I'll take, and then I'll continue forward.
Where's this monitoring service? Like, is it part of the mod anti-malware thing, or?
Okay. So the question is, where is the monitoring service?
About IDS or IPS or something that's maybe sending out some syslog message and it parsing it or something?
Sure. So the question is, where is the monitoring service? In this particular case, the monitoring service is at Daswani.com, and it basically resides in the cloud, right? It relies on a bunch of servers that scan the web server in this case, right? So it's in the cloud, and there isn't a lot of deployment overhead for it, and there's a lot of other advantages that has.
But is that something that's open for someone else can develop?
So the question is it something that somebody else can provide? Yes, absolutely. So actually, I'm going to talk a little bit more about how mod anti-malware works in detail with its configuration directives and its handlers, etc. And today, Daswani is the only provider that produces quarantining directives for mod anti-malware. But one of the things that we hope to do is create the market here, create the infrastructure, and so other providers could also support mod anti-malware. So let me talk a little bit more about the details, but before I do that, I just want to summarize the high-level benefit here and talk about what the world looked like before mod anti-malware and what the world looks like after mod anti-malware. So without mod anti-malware, what would happen is that a site would get attacked. At some point, it would get discovered by the website owners, but in the meantime, users would unknowingly be getting infected, and even after the website discovers that there's a problem, their technical teams would typically be in a crisis mode. Their senior engineers would have to get pulled off of whatever they're doing, figure out exactly where the infection is on the website, what pages it's impacting, what is the infection on the page, what needs to be eliminated out of the files, what needs to be eliminated out of the database to resolve the problem. And so typically, before the existence of mod anti-malware, it would take some number of days for the bad guys to contain, or for the good guys rather, to contain the attack and remove it. During that entire time, the company running the website could get blacklisted and lose their brand, customers, revenue, etc. With mod anti-malware in place, it significantly shortcuts and streamlines the containment of the infections. And the way that takes place is that when a site gets attacked, the monitoring service, in an automated way, discovers and diagnoses the problem, sends in the model that we saw, sends the report to the security team and or to the webmaster, contains the infection once the approval takes place, and so the containment can take place within a matter of hours or even faster, just depending upon how fast the site is monitored and how fast the security team and or webmaster responds. So the containment can happen now within hours or even faster. And then the interesting thing is that even though the site is still in an infected state, there's infections in the files, infections in the databases, wherever, those infections can be removed without having to be in a panic code red mode where the website is losing its traffic, its revenue, its users, etc. So that's what the world looks like with mod anti-malware. I should also mention that mod anti-malware can be deployed in a model where the approval doesn't necessarily need to take place. We, for instance, at Dascient work with a number of web hosting providers, and some of them have basically said, look, I want you to do the quarantining for me automatically. Just go ahead and automatically deploy the quarantining directives. No user or administrator approval required. And that basically makes the containment work pretty much as fast as the website's being monitored. So that's without mod anti-malware. With anti-malware, let me talk more about the details and the architecture. So mod anti-malware is available both as an Apache or as an IIS module. It's structured as an output filter in both cases. The main function is a function called quarantine filter, and I'll provide a schematic on how quarantine filter works. I should also mention there's two versions of mod anti-malware. There's a standard version and there's a light version. We have made the light version open source. So you can go to SourceForge, type in Dascient, and download the mod anti-malware light module. Or you can come to Dascient.com and download the mod anti-malware light module. When you download it from Dascient.com and sign up, we also will provide some free trial malware monitoring for the website that you're using to try out mod anti-malware light. So please feel free to check that out. In terms of mod anti-malware's architecture, there's a couple key things that characterizes its operation. The first thing that characterizes its operation is a set of handlers that the module supports, where a handler is, of course, a URL at the domain. And there's three handlers: statusc, configc, and topc, and I'll talk a little bit about each of those. And then the second thing that characterizes mod anti-malware is the set of configuration directives that it supports, and so I'll also talk about the configuration directives. But let me talk a little bit about each of these handlers first. So basically, if you have a domain like domain.com, then when mod anti-malware gets installed on that domain, the module will respond to requests for domain.com/statusz or domain.com/configz or domain.com/topz. And each of these handlers does something different. So what statusz will do is it will echo what is the last set of configuration directives that was sent to mod anti-malware. Configz will allow the requester to send configuration directives to mod anti-malware. Topz will echo what are the most frequently accessed URLs at domain.com. And the reason for that is because you want to make sure that you're monitoring the most popular URLs most frequently. Because very often when the attackers spread web-based malware, they have a strong incentive to affect those pages that are most popularly used, because that will give them the largest footprint in terms of infecting users. So I talked a little bit about the handlers. Let me chat a little bit about the configuration directives. So there's 4 configuration directives that I'll talk about here. Mod anti-malware supports more configuration directives, of course. But the first one that I want to talk about is a directive called Daswani shared auth key. So you could imagine that you only want certain authorized parties to be sending configuration directives to your mod anti-malware module. You don't want people reconfiguring your web server or stripping out legitimate elements on the page. So that's what the Daswani shared auth key does. Is it allows the webmaster to specify what is the shared authentication key that should be used when the caller, the monitoring service, authenticates to the web server. So that's one configuration directives. Mod anti-malware Lite as well as mod anti-malware support a second configuration directive, which is called set blacklist redirect message. So I talked about mod anti-malware, the premium version, and I talked about mod anti-malware Lite. The key distinction with mod anti-malware Lite is that in the case that a web page gets infected, what mod anti-malware Lite will do is it won't strip out the just the malicious piece of code that's infected, but instead will serve a message of the webmaster's choice and block the entire page from going out. So the idea there is that when mod anti-malware Lite is used to contain a web-based malware infection, then if a website gets infected, then instead of the user seeing the red screen of death from the browser or seeing the other types of messages, the webmaster can choose a message like, this server is experiencing technical difficulties, please come back later, or whatever HTML web page that the webmaster would choose to be served to users, so that even if parts of their site are infected, the rest of the website can continue to be used. And for those web pages that did get infected, the user sees a much less scarier message than otherwise. So the set blacklist redirect message configuration directive does exactly that. The next configuration directive that's supported by mod anti-malware Lite is blacklist redirect URL prefix, and basically it specifies a prefix of URLs for which the regular infected page should not be served, and instead the blacklist redirect message should be served. So in this particular case, it's saying that foo1.html, instead of serving that page, serve the blacklist redirect message. Now, blacklist redirect URL prefix is an example of a quarantining directive, and mod anti-malware supports a number of different quarantining directives, but this redirect message is just one of them. There's other messages that would, for instance, be able to quarantine a particular path in an HTML DOM if that particular path is where the infection is. And there's a number of other mechanisms. The final directive that I'll talk about is a directive called remote directives file, and it basically specifies what is the file on the web server into which all of these directives should be stored. So that's what that particular directive does. I mentioned that there's quarantining directives. There's two kinds. The kind supported by mod anti-malware Lite supports the blocking of infected pages from being served to users, and the full version supports filtering of the malicious code from being served to users. So those are the two kinds of directives. I figured it might be useful to illustrate what happens when a authenticated request is made to any of the handlers. So by the way, all of the handlers require the Dascient shared authentication key to be specified. The request must take place over SSL, it's got to be a post, etc. And so when you make a authenticated request to status Z, what you'll get back is data like this. You'll get back the process ID of the web server process that served it, what its parent was, what was the last time that configuration data was sent, what was the configuration data that was sent, and some data about what are the current configuration directives that are being used by the module. So that's an example of what comes up in status Z. In this particular case, redirection for the foo1.html page is being enabled and the technical difficulties message is being shown. So that's the status Z call. The next call is config Z. It will basically, once it gets called with new configuration directives, it'll output what was the configuration data before the change in configuration data and what was the configuration data after, and it will give the caller a message to let them know whether or not the new directives specified in the config Z request were actually sent to the file. So basically, there's two updates that happen when config Z occurs. The first update that occurs is that in the web server process that receives the request, it will update the directives that are used in memory. It will also write those directives to disk, and the memory that it uses is shared across the web server processes. So the new configuration directives will be propagated to all the different web server processes. Well, that's config Z. And then top Z, if you make a request to top Z, must also be authenticated. You don't necessarily want the rest of the world to know what your most popular pages are. It'll give the process ID, and it'll give all of the URLs and the number of times that those URLs have been requested. Basically, it uses a bounded hash table to store the topmost requests. So that's those are the handlers. In real life. And I thought it might be useful to just kind of walk through the main loop of the quarantine filter function, which is at the heart of the module. The first thing that happens whenever any request is made to the web server and the mod anti-malware module is invoked is it will update the bounded hash table that is responsible for responding to the top Z request. It will then, for each URL prefix that there exists quarantining directives for, it'll check. Or actually, I'm sorry, I'm talking about the mod anti-malware light architecture here. So it'll look for each URL prefix for which there's a blacklist URL prefix directive, and will check whether or not the URL being accessed is for that URL, and if it is, it will basically serve the redirect message and will construct a completely new bucket brigade. For those of you that are familiar with Apache and its architecture for modules, it keeps a passive set of buckets that go through processes. And we'll construct a bucket brigade with the blacklist redirect message and serve that. If not, if we shouldn't do a redirect, the one other thing that it'll do is it will send a HTTP response header called xquarantined1. And the reason that's important is because what the monitoring service does as one of its value adds is after quarantining directives have been sent, it will verify whether or not all of those quarantining directives have successfully went into effect and malware is no longer being served by the website. So the monitoring service can use the xquarantine directive to figure out for a particular URL, is the module doing something? If the module is doing something, and for instance, the page is no longer infected, then you're in good shape. The infection has been contained. On the other hand, if the module is doing something and serves the xquarantining directive and the malware is still coming down, then basically the monitoring service can send a upgraded quarantining directive. And actually, we have a white paper describing mod anti-malware and all these details. You can check it out on the Blackhat CD. But in any case, if you don't need to do a redirect, then you just go through the standard set of Apache functions to then take the output filter out of the loop and pass the brigade of content to the next module. So another couple interesting things about the implementation. I mentioned authentication. This is a screenshot of the configuration that we have at Dascient.com for a particular for a particular mod anti-malware module, you see that when a domain is added for monitoring, it provides a Dasient short authentication key. It reports on whether or not the module is enabled. And basically, once somebody enters this particular screen, the monitoring service places a status Z request to ask the module, hey, are you okay? Are you operational? Are things good? And that's why we get back an OK message. So authentication is a interesting part of the implementation. Quarantining verification, I also mentioned, is an interesting part of the implementation where the monitoring service can check whether or not the module is doing something and whether or not the page is still infected, and decide if more drastic containment is necessary. In addition, I had mentioned that when directives get sent to a web server process, that web server process updates its configuration directives in shared memory, and it basically shares that set of directives with other web server processes so that the web server doesn't need to be restarted to use these new configuration and quarantining directives. And then of course it writes the new directives to disk such that when that web server is restarted, it uses the latest set of configuration directives. So there's a lot of future work that we're doing, and for those of you that are interested, there's some Mod Anti-Malware Lite open source projects that are available. So one of the things that we're in the process of doing is adding virtual host support. So currently, if you have a dedicated web server, Mod Anti-Malware Lite works as is. We would like to extend it to support virtual hosts, such that if you're serving multiple websites from a given dedicated server, it will do the quarantining appropriately. So the virtual host support is one area. In addition, right now we have shared key authentication with a fairly long shared key, but we can also support, or one area that we'd like to support is certificate-based mutual authentication, where you can basically deploy a cert on the web server, and there's a mutual certificate-based authentication. I'm sorry, on the web server right now, it does check whether or not HTTPS is running and whether the request comes over SSL, but basically the monitoring service could use a certificate to prove itself as a client to the Mod Anti-Malware module. That's a future work project that's available. And then we're also working on supporting automated deployment of quarantining directives. So for those of you that like hacking on open source projects, please come up to me afterwards and let me know. So, where can you learn more? There is a SourceForge page that we have for Mod Anti-Malware. You can check that out. You can download it from there, check out some of the documentation. If you're interested in learning more about the monitoring service that Dasient offers, you can check out our website, our blog, our Twitter feed. There's a lot of different resources you can check out. If you're interested in this general area, I have a lot of publications and resources on my own personal homepage at neildaswani.com. If you're interested in general in web-based malware attacks, in web security, I'd encourage you to check out Stanford's security certification program. Let's see. So that's one area to learn more. And if you want to learn more about web application security, there's my book, Foundations of Security. I'll be raffling off a copy in just a second. The book has a website, so you can actually access not only the errata, but both at that website as well as at Google's Code University. There's a set of downloads that are available. We've made available chapters corresponding to, we've made available slide presentations corresponding to each chapter of the book on that website. And so if you need to educate a large number of folks, say, at your organization about security, this book is one great way to do it. The book covers not only security principles, but it covers web-based attacks, SQL injection, cross-site scripting, client state manipulation. It has a chapter on cryptography as well, or a section rather on cryptography as well. So there's pretty good foundational coverage for you if you need to help enable an entire organization to learn more about security. So I think those are the key things that I wanted to cover. I think there's a lot of progress that we need to make in the field in general, and through technologies like Mod Anti-Malware, it'll be great to not only be able to detect attacks but contain them. And the hope is that we can curtail the spread of web-based malware by using technologies like this. In any case, I I hope that some of you may be interested in working together with us on this. More than happy to work together not only on this front, but I think what I'll do is bring my talk to a close by just saying that the internet's been a great platform for all kinds of new ways to conduct commerce, communicate, and collaborate. And I look forward to working together with the community to continue to make sure that the cyber criminals don't turn it into a wreck for all the good users that are using it in various ways. Thank you. So I guess what I'll do at this point is I'll take a couple questions, and then I'll raffle off a copy of my book and invite folks to come up and pick up passes for our private party. Question?
Oh, thanks. Got a microphone in my face. The way it's implemented is you need to connect to my web server via HTTPS, right?
A monitoring service like ours would need to connect to your web server. That's correct, via HTTPS.
Is it not possible that, for people who aren't currently allowing inbound HTTPS connections because they don't have secure parts of their site, could you not implement it the other way around, so that I provide you with information and asynchronously in the background, and you update me on whether what I'm doing is
that is an implementation possibility. The key thing there is that the polling frequency would. So one of the advantages about the monitoring service making a call is that most websites expect inbound calls anyhow, and basically the second that an infection is detected, the quarantining directive can be sent. If you implement it the other way, which is a deployment model that could work for some organizations, if you implement it the other way, then sometimes there might need to be a request that takes place from within the firewall outside, which could look like something malicious is going on. And then the important thing is that if that deployment model is amenable to an organization, then the polling frequency would have to just be often enough such that if there is an infection, you want to make sure that polling frequency isn't too large, because then the site could be exposed to be serving web-based malware infections during the interim between polling.
But you're not going to call me every time you know some new dangerous intelligence about the web, right? Otherwise, you'll be making connections to my web a million a second.
The monitoring service, our monitoring only makes connections when an infection has been detected and quarantining directives need to be deployed.
When something's been detected on my site?
On your site, that's correct.
Okay.
Great.
Thanks.
There's another question?
On the same subject, would it be possible to do like a self-sign certificate? His example was, if there's... Would it be possible to do a self-sign certificate? His example was if there's a bad... or you don't have a certificate for your website, but you still want to be monitored. Would it be possible to have your monitoring service accept a self-signed certificate so that they don't have to go out and get certified?
Yes, that is possible. So the question is, can you use a self-signed certificate? The answer is yes. Great, very good. Okay, I think what I'll do is at this point, I'd be happy to take more questions offline, but let me do this. Let me raffle off a copy of my book first. So here's a question. Can somebody name one of Dacient's investors? So first of all, I need a hand. And there's a hand off there to the left. Google. So Google is not currently an investor in Dacient. Another try? Stratton Sklavos, that's correct. Stratton Sklavos, the former CEO of VeriSign, is one of Dacient's investors. Please come up for a copy of your book and give him a round of applause. Or he'll come up and get it afterwards since he's embarrassed to come up. I don't know. Great. Okay, wonderful. Well, other than that, I appreciated the opportunity to come tell you all about mod anti-malware and how it works. My hope is that what we can do is use technologies like this to complete the life cycle of malware protection for websites and web servers. Please feel free to send any questions about it. But if you're interested in coming to a private party that Dacient and Senzik is throwing this evening at 9 p.m., we're going to have food. We're We're going to have drinks. It'll be a lot of fun. Just come up, and I'd be happy to give you a private party pass. So see you guys all at the party.